In this video, we will talk about linked list, which is another list-based data structure in the Java collection framework. Now, we know that array list is implemented using arrays, but in case of linked list, it is a node-based data structure. It means for each value or for each entry, it has a node, and these nodes are connected to each other using pointers. In Java collection framework, linked list is an implementation of doubly linked list. Okay. So in the case of linked list, we have nodes, and these nodes are connected to each other using next and previous pointers. There is a head and there is a tail in the linked list. As you can see that linked list uses nodes to store the data, which doesn't have to be on contiguous memory locations, same as arrays. So the benefit is we don't need to resize the array. If we need a new element, we can simply add a new node in the list. We can update the pointers and simply update the tail or head accordingly. It is as simple as that. Also, it is easier to remove or to delete an element from the linked list. So consider the case when we delete an element from the array list, it is removed from the internal array. After deleting the element from the array, the elements needs to be shifted. But in case of linked list, if we are deleting a value, it is as simple as deleting a node. For example, let's say if we delete this value, then this node will be deleted. All we need to do is we need to update the pointers in the list like this, and it's done. So you can see some benefits of using linked list, but having said this, this is not actually recommended, not anymore at least. Array lists, although it is using arrays internally, but they are much faster in general. So it is always recommended to use array list or some other custom or specific specialization of list. The reason behind that is linked list is not only implementing the list interface, it is also an implementation of deck and queue. So that means if we are using a linked list, not only we can add elements to it same as the list, but we can also use it as a stack or as a queue or as a deck even. So it has the support to add the elements using push and pop, same as stack. Then the front and the rear of the list, they are available for us to do some operations. So we can add element at the front here. Similarly, we can add element at the rear. We can also remove element at the front and similarly at the rear. That is not supported in the array list, but there are now specializations of queues and decks, so this class is not recommended anymore. If we need a functionality of queue, then there are other queues that we can use. So this is the theory. So this is the theory part of the linked list. Now let's move on to the demo. Let's see a quick demo. This video is going to be a short one because there is not much to cover on the linked list. Okay. So let's start with how to initialize a new linked list. To do that, we use the class linked list. Let's say we are storing integer values. So we say ll equals to new linked list. To add an item, we can use the method add one. Let's add another item. How do we get the item back? To get the item back, we can use get by passing an index, get last, get first, because this also implements the deck interface, so we can do operations at the front and at the rear. That's why we have the support to get the items, first item from the front and the last item from the rear. So let's use that. Let's use the get first and then get last. If we run this, We see the first item is 2 and the last item is, sorry, the first item is 1 and the last item is 2. By default, when we use the add method, it adds the elements in a sequence. First one, then 2. But we can change the sequence. What we can do, maybe, let's say, now that we know first 1 is the first item in the list and 2 is the second item in the list, but we can change the order. We can say that add first 3. We want to add 3 at front. Okay. This time, if we print the same thing again, then we see the first item in the list is now 3. The last remains the same, which is 2, but the sequence is now changed to 3, 1 and 2. So when we add 3 by using add first, 3 is added at the first location, then it was 1, and then in the last we see 2. So we can add items to the list using add first, add last. Now let's say we want to add an item in the last, at the last position. So what we can say, we can use an item by using add last, and let's print the same thing again. And if we run it, we should see 5 in the last. Here it is. So the new sequence is now 3, 1, 2 and 5. Apart from this, linked list also supports push and pop operations, same as stack. So if we push a new value, let's say 6, it will be pushed at the front location, same as the top of the stack. So the new sequence would be something like 6, 3, 1, 2 and 5, because we are pushing the value. And if we pop the value, then we will get the value from top of the stack, which is 6. So the last println should print the value 6. So we see value 6 on the console. These are the main methods of the linked list. Apart from this, everything that we have seen in the array list applies here as well. So for example, we have add, where we can add the value at a certain index, get value by index, add all if we want to add values in bulk mode by passing a collection. Okay, we can clear the list by using clear method. We can get the index of elements by using index of last, index of iterator, offer. The difference between offer and add methods are that if we are using offer or offer first and offer last, it returns a boolean if the element was added to the list. Similarly, we have peak and peak first, peak last, poll and poll first. That is the main difference, because when we use peak or poll or offer, they return a value. But in case of add first, add last, they don't return a value. So if you go to the add first, you see it does not return a value. It tries to add the item. But if we go to the, let's say, offer, then it returns a boolean. Okay, it returns true if it was able to add the element to the list. So that's pretty much it on the linked list. I would repeat my words that it is not recommended to use linked list due to its memory consumption. But if you think you have a use case, it's always better to test the code, to test the performance. All right.